Doctor, if you're talking, we cannot hear you.
You are not able to hear. Now you are hearing me?
Yes,
now
we
yes.
didn't hear anything before.
Okay, sorry. It was muted. Okay, I will repeat. Okay, I will repeat
Okay, for sure.
everything. Okay. So, in this chapter, we will study equilibrium of a rigid body. Okay, as we mentioned previously, we have particles and rigid body. For a particle, we can neglect the volume. So in order to have equilibrium, the condition is sum of forces equals 0. However, for a rigid body, we have two conditions to have equilibrium. The first one is that sum of forces equals 0, and the second one is that sum of moment is equal to 0. And these are two vectorial equations. Each vectorial equation has three components. For sum of forces equals 0 as a vectorial relation, we can write sum of x equals 0, sum of y equals 0, and sum of z equals 0. And the same for sum of moment equals 0. It can be divided into x, y, and z components. So in 3D, for a rigid body, we can end up with 6 equations, and we will be able to solve 6 unknowns. Now, in case of 2D, sometimes we have rigid body equilibrium in 2 dimensions. In 2 dimensions, how many equations we will have, do you think, for equilibrium?
4.
What are the 4 equations?
Sum of fx, sum
Yes.
of fy,
Yeah.
and sum of moment x, and sum of moment y.
Do we look when we have forces in xy plane? Can they produce a moment about x and y?
Ah, okay.
So moment about what only?
Z.
Yes.
About z.
About z. Okay. So when you have 2D equilibrium, you have only 3 equations. Why? Because your moments will only be along, all forces are in xy plane, so they can only produce moment about z axis. And for sum of forces equals 0, you'll have 2 equations. So in 2D, the 3 equations will be sum of x equals to 0, sum of y equals to 0, and sum of moment about point O, which corresponds to sum of moment about z equals to 0. Okay. Now, in order to find, if you want, our unknowns, we need to know what are the type of reactions that can be subjected, that can a rigid body be subjected to. Okay. So first, before starting doing problems on equilibrium, we should know what are the most important common connections that we face in 2D. So we have the possibility of a roller, of a pin, of a hinge. So let us look at these types of connections. First, the roller is represented by the following symbol. It's represented by a circle like this. And in general, you can see it's like this. In figures, they give it in this way. A circle plus this. Okay, this is the representation of a roller, and you can see it also here in this figure. So you have the circle. What in the case of a roller, you only have a reaction that is perpendicular to contact. Okay, it's like a wheel. If you want, it will not. It can slide in the x direction, so you will only have a force in the perpendicular direction. So when you see a roller, it will act only in a reaction that is perpendicular to contact. Okay. So now the second type of connections is pin. The pin is in general represented as you can see here, or it will be like this. You have a triangle. When you see a triangle like this, okay. So this is a pin. the pin will develop two reactions, one in X and one in Y. Okay, so in this case, the reactions are an X reaction and a reaction in Y. And the last type is hinge. Okay, sorry, the last type is fixity or fixed support. As its names indicate, it's fixed, so I cannot do any motion in 2D with respect to it. So it will oppose motion in all directions. It will oppose a motion in X. It will oppose motion in Y. This is why it will develop a reaction in X, a reaction in Y, and also it will not allow for rotation. So it will develop a resistant moment M. Okay, so always if you want to know what are the types of reaction, you should think about what is this reaction opposing. In the case of the roller, you can slide your beam like this, so it will not develop a resistance along X. You can rotate your beam, so it will not develop a moment. It will only prevent you from going in the downward direction. This is why it is giving a force that is perpendicular to contact. For the pin, you cannot displace in X and Y, but you can rotate. You can rotate about the pin. Okay. So this is why it will develop Fx and Fy. While for the fixity, it's embedded in a wall, for example. You cannot do anything. You cannot slide in X. You cannot slide in Y. You cannot rotate. So it will develop Fx, Fy, and a couple. And in general, the symbol of the fixity is like this. So this is a symbol of the fixity. Okay. Now, other types of connections. Sometimes they tell you we have a smooth surface. When they say smooth surface, what do they mean by this? We don't have friction, okay? And if we don't have friction, then the surface will only develop one reaction that is perpendicular to contact, okay? So no friction, this means that the object can slide freely without a resistance, and only the surface will develop a force perpendicular to contact. Now, when they say rough surface, okay, or surface with friction, so here just it's surface with friction or rough surface. Sometimes they say rough surface. This means that the surface will develop a friction force. This is why when considering the object, we will have Fx and we will have Fy. And this type is the one already we have seen previously, the roller. So every time you see like small wheels, it's a roller. Roller or bearings, they will develop also a force perpendicular to contact because in X direction they can slide. Okay. Now here you can see more clearly the pin or hinge. So as you have a screw here, if you have a screw, you cannot go up, you cannot go in the X direction, but you can rotate. You can rotate around it. This is why it will develop Fx and Fy. And this is the fixity or the embedded reaction. So you have Fx, Fy, and the couple. Now you have also other types of connections. You have the cable. We have already seen the cable in the case of particle, and we said that a cable is always in tension because it cannot sustain compression. Okay, and in this case, the force will always be directed along the cable in a way to cause tension. So here, if you represent the force of the cable on the bar, it will be downward because the force of the rod on the cable is upward because it is in tension. Now, the main difference between a cable and a weightless link is that for the weightless link, the force should be can be tension, can be compression. So when you have a link, you might have a force of tension or a force of compression. So it can be in both directions. This is the only difference between cable and weightless link. And why they say weightless, it's very important because if it's not weightless, you can have the reaction not along the link. So when they say weightless link, this means that the force should be along the link. Now, another possibility of reactions, you can see it here. You have a member that is pin connected to collar on a smooth rod. So here, what do we mean by this? If you want to know what is the reaction developed, because the pin is now mounted on or connected to a collar, and the collar can slide on the rod. Because the collar can slide on the rod, do you have a resistance in this direction? No resistance of motion in the following direction. So what will happen? You can only have a resistance along this one. This is why here, because the collar can slide, you will not have an X force, you will only have a reaction along the perpendicular to motion, which is Y. And since it's a pin, you already can rotate, so no resisting couple. Now, another possibility is a member fixed connected to a collar. If you have a fixed member connected to a collar, then what will happen here? Because it's a fixity already, you cannot rotate. But now, because it's related to a collar, it can slide. So the two reactions will be the force F and the couple M. So at the end, for any reaction, okay, you should say what are the things that my connection is opposing. If it's opposing rotation, then I have a resisting moment. If it's opposing motion in X, then it will develop a reaction in X. Okay, and the same for Y. Any question on the connection types?
Doctor,
Yes. Yes.
how is the member pin not having a resistive moment?
Okay, for the pin, it's like you have a screw here. Okay, here you have a small screw, like as you have a screw, so you can rotate about. Okay, so this is why when they say pin, it means that you can rotate about it. This is why it will not develop a resistance moment. Okay, while uh,
Okay,
while for
okay.
while for the fixity, look here, you don't have a pin. It's just one port. This is one port. Okay, since it is one rigid part, so you cannot do any rotation here in this case. It's like this. It's one part, so it cannot do rotation. It can only slide. This is why the resistance forces are force along perpendicular to contact and the couple. Okay.
Okay, thank you, doctor.
Yes, Naim. For the collar part, look, the collar is, if you want, is a sliding object. So the collar can slide. If you attach a member to the collar will be able to slide along this direction. And if it is sliding, what will happen? Because it will slide, then you will not have resistance to motion along the sliding direction. This was the case here, and this was the case here. Because your member here can do translation here due to the collar, because it's attached to the collar. So when you have a collar, you will not have a resistance force in the direction of motion of the collar. Okay? Now we will see examples on equilibrium in 2 dimensions. Okay, so if you have the following body, for example, and you have several forces acting on the body, as you can see, this symbol, if you remember, is for what? When you see a triangle, this is the symbol for a pin. So it's called pin or hinge. And the pin will allow only rotation. So it will develop forces in X and Y directions. Now for B is a roller because you have the circle here. So for the roller, it will only develop a force that is perpendicular to contact. So here, what you have here, at A, you have AX, AY, and at B, you only have the BY reaction. Okay? So now, if you look at your problem, you have 3 unknowns, BY, AY, and AX. Okay? So you need 3 equations. As we mentioned previously, you can use sum of x equals 0, sum of y equals 0, and you can choose sum of moment about any point you want in your figure. Sum of moment about A, B, C, or D, any point, it will give you the third equation. Now please pay attention for a thing. In 2D equilibrium, if you write a force relation, it will be a repetition. So no way to solve, for example, for 4 unknowns. And if you tell me, I can say, because I can do sum of moment about any point, why I use, for example, I can use sum of x, sum of y, sum of moment about O, and sum of moment about A, for example, and I will obtain 4 equations. No, it's wrong. Why? Because if you write 4 equations, you will see that one of them will be a repetition of the others. So you cannot solve more than 3 unknowns in equilibrium in 2D. And if you have a force unknown, you should think about another equation to solve, different than the equilibrium equation. Now, what I want to tell you that you can replace a sum of force equation by sum of moment. It's not wrong. And for example, here in this figure, you can say instead of sum of x, I want to do, for example, sum of moment about B equals to 0. It's not wrong. So your 3 equations become sum of moment about A equals 0, sum of moment about B equals 0, and sum of y equals to 0. You can also do 3 moment equations. So you can do, instead of these 3, you can do sum of moment about A equals to 0, sum of moment about B equals to 0, and sum of moment about C equals to 0. So you can choose any combination of 3 equations you want. It's up to you. And you will see that it will depend on the problem. What is more simple to do? Sometimes sum of moment will be simpler than sum of force. We will see how together. Okay? So, as we said here, we can replace a force equation by sum of moment equation. So, for example, you can do the following: sum of x equals 0, and sum of A equals 0, and sum of B equals 0. Or even you can do 3 moments equations. Let us do an example to see in general how we select the corresponding equations to use. Okay? So, let us start first by the following example. As you can see in this figure, you have here a pin and you have here a roller. So directly you can say that at A I have RAX, RAY, and at B I have RBY. Okay, and I want to find what will be the developed reactions. So how many unknowns do I have here? I have 3 unknowns: RAX, RAY, and RBY. Okay, now to start with, I want to find RB, let's say. Who will tell me what is the easiest equation to find RB? If you look well at the figure, what is the easiest way to get RB? Can you give me an
Sum of
equation?
moments
The moment at
at
A.
A.
Yes, very good. Sum of moments about A. Why? Because if you look at your figure, RAX and RAY pass by A. Okay? So if you do sum of moment about A, RAX and RAY will not have any moment. And only RBY will have a moment. So if I do sum of moment about A equals 0, and I choose a positive direction, I can choose the positive direction that I want. For example, if we choose the counterclockwise as positive, so we will put this close to the equation, we will put the arrow like this, that we are working in the counterclockwise direction. Now, RBY is producing a moment in the counterclockwise about A. I should multiply by which distance? The distance between A and RBY, which is equal to 2 meters. Okay, so I do RBY times 2 first. Then I have the moment of the 2 kilonewton force here, and it's producing a moment in the clockwise direction, because look, if you do the right hand rule, or if you do with your pencils, you can see that this force is producing a moment in the clockwise direction. Okay, and the same for this one, it's producing a moment in the clockwise direction, so they have negative moments. And now, to know by which distance I should multiply, I will look here at this 2 kilonewton force. It is at a distance of 1.5 meter, so it's minus 2 times 1.5. And for this one up, the distance is from here to here is 1.5 plus 1.5 is 3, so it's minus 2 times 3. And this equation will directly give me RBY equal 4.5 kilonewton. Okay, so here using sum of moment about B will allow me to directly solve for RB. Now, in order to find RAX, what is the easiest equation, of course, here? Do you have another force than RAX as unknown in X direction? Your only unknown in X is what? Is RAX. So to find RAX, the easiest way is to write sum of X equals 0. If you write sum of X equals 0, you get 2 plus 2 plus RAX equals to 0. So you deduce that RAX is equal to minus 4. Okay? And now along Y direction, already you have found RBY. So now to find RAY, all you have to do is to write that sum of Y equals 0. You get the value of RAY. And pay attention for something. Always you assume a direction when you put your force here. Okay? So I assumed that RAY is upward. So when I solve, I obtained a negative result. This means that in reality it is downward. Okay? And for AX also, I choose the wrong direction because RAX will be directed towards the left. So you can keep it here like it is, but you put here it's equal to a negative value. Any question on this problem?
Please, can you repeat كيف جبنا RAX?
Yes. If you write sum of forces along X equals to 0, what are your forces along X of this body? Look at your figure. What are forces along X? This is your X, this is your positive X. You have plus RAX plus 2 plus 2. Okay? So it's 4 plus RAX equals to 0. So RAX is equal to minus 4. Okay? Who can give me another method to find RAY? Instead of doing sum of Y equals 0, give me another method to find RAY. What should we do? What is the other possibility to do?
Of moments on B.
Very good. Sum of moments on B. So if I do if I do sum of moments about B equals to 0, okay, I have RBY is already passing by point B, and RAX also is passing by B, so no moment for RAX and RBY about B. What I will get is, if I choose the clockwise as positive, so always please specify your positive direction. In 2D, always put with your equations the positive sense you are considering. If you now consider positive along the clockwise direction, the equation will be the following for sum of B, sum of moment about B. You have a positive moment for RAY because it's trying to rotate clockwise about B. So RAY is trying to rotate clockwise about B. So it's plus RAY times this distance, which is 2 meters. And for the 2 kilonewton force, it's also trying to rotate clockwise about B. And for this one also. So here all your moments are in the clockwise. This is why you will expect that RAY will be negative. The value of RAY you get will be negative to oppose the couple of these two forces. Okay, so when I write sum of moment about B equals 0, I have a plus RAY times 2 plus 2 kilonewton. The first 2 kilonewton force has a distance from B equal to 1.5. So times 1.5 and plus 2 for the second force, it's plus 2 times 3 equals to 0. And you will get RAY, if you solve, you will get RAY equal to minus 4.5. Okay, so here you always have several possibilities to calculate your reaction. So it's up to you to choose the 3 easiest equations. Any question on this problem? Another example. Find the reactions at A. So here, as you can see in this figure, this represents what? This symbol is for what? If you remember.
Fixity.
It's a fixity. Yeah. So this is a fixity. So when you see a fixity, this means that it will develop 3 reactions: RAX, RAY, and a couple resisting moment at A. So to solve for the reactions at A, we have here 3 unknowns. We need to write 3 equations. Okay? So first, for
دكتور إذا
RAX.
في fixity بيكون في moment.
Sorry?
إذا في fixity بيكون في moment.
Yes. When you have a fixity, you have a resisting moment. Okay? So here, first, in order to find RAX, you don't have any force along X direction other than RAX. So if you write sum of X equals 0, it will give you that RAX is 0. Now, in order to solve for RAY, also it's very simple here because you have only one other force along Y. So you can do sum of Y equals to 0. It will give you plus RAY minus 2000 equals to 0, and you get RAY. Now to get your couple, MA, you can do sum of moment about any point in your figure. You can do sum of moment about A equals 0, or sum of moment about B, or sum of moment about C. But what is the easiest point to select? What is the easiest point to do sum of moment about?
A.
Yes. Why? Very good. Why A? Because when you choose A, you will cancel the moment of RAX and RAY. Since these two forces pass by A. Okay, so now if you write sum of moment about A, what do you have? You have, please pay attention, the couple is a free vector. So when I do sum of moment about A, I will account for all moment couples and for moment of forces. So when I do sum of moment about A, so the general formula is that sum of moment about A is equal to sum of moment of couples, okay, plus sum moment of forces. Okay, so you always have forces and couples. So here, this is a couple moment. MA is a couple moment, and at B also you have a couple moment. So when you do sum of moment, and we will choose a positive direction, let us say the counterclockwise is the positive direction. So you have plus MA, and also you have this 3000 moment is along the counterclockwise direction, so it's plus 3000. Now you still have moment of forces, okay? For Fx and Fy, they will not produce any moment about A because they pass by A. So we'll only have to find the moment of this force. And the moment of this force is clockwise or counterclockwise? Look, this force, look, this force is trying to rotate about A in which direction? Like this. So it's producing a clockwise moment. This is why its moment is negative. So minus, so I will write minus 2000 times which distance? I will take the distance, the perpendicular distance from A to the force, which is equal to 3 plus 2, 5. So it's minus 2000 times 5, okay, equals to 0. And now, from this equation, I can get what is the value of MA. Okay? Now, if I want to use another method, okay? If I want to find the MA by doing sum of moment about B, for example, let's try. So if I do sum of moment about B, this is another possibility, equals to 0. What do I have? And I will also choose the counterclockwise as positive, like this. Yalla, who will tell me what will be my equation if I do sum of moment about B equals 0? Look, the session will stop, so I will open another one, okay?